So, very good afternoon. I am Professor M.K. Bhuyan, the course instructor of the course Computer Vision and Image Processing Fundamentals and Applications. This is the second live session of the course Computer Vision and Image Processing Fundamental and Applications. So, if you have any questions, then you can discuss with me in this live session. So now I have seen no questions in the shared doc file. Just now I have checked the questions in the doc file, but I have not seen any questions in the doc file. So if you have any questions, then you can interact with me in this live session. And up till now we have covered week number 7. So if you see the course outline, in week number 1 we discuss mainly the fundamental concept of computer vision and image processing, and also we discussed the concept of image formation in week number 1. In week number 2, we discussed again the concept of the radiometry and the concept of the image formation. And one concept is the geometric transformations and also the geometric camera models. So one important point is the concept of the affine transformation. So how to do the rotation, how to do the scaling, how to do the translation. So this is about the affine transformations. And also we discussed about the geometric camera models, like the perspective camera model, orthographic projection, orthographic camera model. So all these camera models you have to understand. That is in week number 2. In week number 3, again, we are continuing the concept of the image formation. And I discussed the concept of the camera calibration. And also one important discussion was the image formation in a stereo vision setup. So how to determine the disparity, and from the disparity, how to determine the depth information. So that is one important discussion. And what are the problems of finding of stereo correspondence? Stereo correspondence means the matching of the left and the right image. So how to find the correspondence between the left image and the right image? That is the concept of the stereo correspondence. So that point is also important. And after this, I discussed the concept of image reconstruction from a series of projections. And that is nothing but the concept of the radon transformation and also the inverse radon transformation. So in the radon transformation, I have shown how to find a projection corresponding to fxy. So suppose object is fxy, and how to find the projection corresponding to fxy. And for reconstruction, I have discussed 2 techniques. One is the back projection technique. Another one is the Fourier transform technique. So these 2 techniques are quite important. The concept of the back projection, and another one is the projection theorem. And that is nothing but the Fourier transformation. That is in week number 3. In week number 4, we discussed the concept of image transformation. So what is the definition of image transformation? The concept of the Fourier transformation, the concept of the discrete cosine transformation, and concept of suppose 2 random variables, how they are uncorrelated, and the concept of the energy preservation. So these concepts I discussed in week number 4. In week number 5 also the same concept, the image transformation we have discussed, the concept of the DCT wavelet transformation. So that you have to understand. And after this, we also discussed the concept of the image enhancement in week number 5. So how to improve the visual quality of the image, how to remove noise, the concept of the contrast enhancement, the histogram equalization technique, histogram specification technique. So this is in week number 5. Week number 6, we discussed the concept of the image filtering, that is in spatial domain and also in the frequency domain. So in the spatial domain, we discussed the concept of the low pass filter, high pass filter, and also the high boost filter, and concept of the median filter. And in frequency domain also, how to consider the Fourier transformation. So first image has to be multiplied by minus 1 to the power x plus y. And after this, we have to determine the Fourier transformation. And after this, we have to consider the frequency response of the filters, the low pass filter, high pass filter, or the high boost filter. And after this, we have to do the multiplication, because convolution in time domain is equivalent to multiplication in frequency domain. So after this, after doing the multiplication with the filter transfer function, we are getting the process image. And after this, we have to do the post-processing. So that means again, we have to multiply it by minus 1 to the power x plus y, and I'll be getting the filtered image. So that is in the frequency domain. So two techniques, one is in the spatial domain, and another one is in the frequency domain. After this, I discussed the concept of the color image processing. So different color models like XY color model, RGB color model, or CMY model, CMYK model, SSI color model, YCBC color model. So all these models we have discussed in the color image processing. And one discussion is the concept of the pseudo coloring. Pseudo means the false coloring. So how to convert the grayscale image into the color image, and also the concept of the color balancing. So that I discussed in the color image processing. And also I have highlighted the simple median filter I cannot apply in case of the color image. So for the color image, I have to apply the vector median filter. So that concept also I discussed in color image processing. And after this, I discussed the image segmentation techniques like the split and merge technique, region growing techniques, active contour technique, and K-means clustering. So these type of techniques I discuss in image segmentation. And currently we are discussing in week number 7, that is the concept of the image descriptor and the features. So for this, we are discussing the concept of the texture descriptors. What is the GLCM, the gray level co-occurrence matrix, and also the concept of the Gabor filter, the Gabor features. And also we discussed about the color features and the edge and the boundaries, how to determine the edges and the boundaries. So this is in the week number 7. So up till now, we have covered up to week number 7. So in the next week, week number 8, we will be discussing the image descriptor and the features. So the concept of the object boundary and the shape representations. So that point I will be discussing. And after this, in week number 9, two important concepts. One is the interest point or the corner point detection. And one is the histogram of oriented gradients, shift feature, the scale invariant feature transformation, and also the speeded up robust features and concept of the saliency. So that is in week number 9. Week number 10 is mainly the fundamental concept of the machine learning, because we have to do the classification or we have to do the recognition. So that is why the fundamentals of machine learning. And in week number 10, so mainly the concept of the Bayesian decision making, linear regression, parameter estimation, the PCA, the principal component analysis, linear discriminant analysis in week number 10. In week number 11, again, we have discussed the concept of applications. In week number 11, actually, I am going to discuss the applications of computer vision like artificial neural network for pattern classification, convolutional neural networks, autoencoders. And finally, in week number 12, some applications like gesture recognition, motion of estimation like optical flow, object tracking, and some programming assignments. So this is the course outline. And up till now, we have discussed up to week number 7. So if you have any questions, then here in the chat box, you can write your question.
Sir, I have some questions.
Okay.
Sir, I'm P. Model, sir. Sir, may we get the solution for the assignments? Because some of the assignment I'm stucking and I need to discuss those assignment. If you can provide the solution, then it is okay. Otherwise,
okay. Solution actually the TA already I told them to upload in the portal. So maybe by next week they will upload all the solutions of the assignments up to week number 7. Is it okay?
Sir. Is it okay? Sir, yes, sir. And there is another question from my side.
Also, you can directly contact them also. In the last live session, I have given the email ID of the TAs. Do you have the email ID of the TAs?
Yes, sir. Yes, sir.
So you can directly send the mails to them. And also maybe the next week, they will upload all the solutions up to week number 7.
Okay, sir. Okay. Sir, I have another question, sir. Can you explain me with some example of K-means clustering, sir?
So K-means clustering is a technique that is the unsupervised clustering technique. So suppose you have some data points, okay, and it is in the feature space. And suppose I want to do the clustering. Clustering means grouping. So how to do the grouping? Sir. Grouping is done by finding the similarity. So the similarity we can determine based on some measure. So maybe we can consider the Euclidean distance also we can consider. So suppose I have a feature vector, another feature vector is there. So I can find the similarity between this feature vector based on the distance, the Euclidean distance. So in the feature space, what I can do, I can select randomly, suppose 3 centroids. Okay, 3 centroids. Suppose 3 centroids corresponds to 3 clusters. Clusters means the group. So after this, what I can do, suppose one vector is there, and I have to find the distance between that vector and the centroid. So I have 3 centroids corresponding to 3 clusters. So suppose one vector is there. So I have to find the distance between the centroids and the vector. And based on the minimum distance, which one is the minimum distance? Based on this, I can assign the vector to a particular cluster. So suppose distance, in one case, the distance is minimum. So that vector is assigned to that particular centroid. Like this, for all the vectors, I have to do this. Okay. So first I have to do the randomly select the centroids. So have you seen my video here in K-means clustering?
Centroid selection is random process.
No. Randomly I have to select the centroids.
Okay.
So you have not seen that. I can share the video also. Let me check. Let me check that how to explain this one. I have a video. Okay. So I am sharing my screen. Sharing the screen. Is it visible? The screen is visible now?
Yes, sir. Yes, sir. Yes, sir.
So how to do this K-means clustering? Suppose we have these data points. Yes?
Yes, sir.
So now I have to randomly select the centroids, initial centroid. So suppose these 2 centroids, one is the red, another one is this green. So that means yes, I have 2 clusters. So this information I am giving that I need 2 clusters, and corresponding to these 2 clusters, I am defining the centroid, and that is randomly defining. So one is suppose red centroid, another one is the green one. After this, I have to find the distance between these data points. Suppose one particular data point is there, and I have to find the data point, the distance between the data point and the centroids. And based on the minimum distance, I have to assign that data point to a particular centroid. Suppose corresponding to a particular data point, the distance to the red is minimum as compared to the green. So that means that data point, I have to assign to the red centroid. So you can see here. So based on this, I'm assigning these points to the red cluster, and these are the green points that are assigned to the green one, because the distance is minimum.
Okay.
And for this, we are considering the Euclidean distance. So you can see the red points are assigned to the red one, and the green points are assigned to the green one. That is based on the minimum distance. And after this, we have to recalculate the centroid, because after assigning this, the centroid will be different. So for determining the centroid, we have to consider all the vectors, the red vectors, and we are determining the mean of this. So mean of this is this. And for similarly for the green also, we have to consider all the green vectors, and we have to find the mean. So I am having the new means. The red one is the new mean, and the green one is the new mean. So that is in the first iteration. After this, again, I have to do this process. Repeatedly, I have to do this process. So based on the minimum distance, I have to assign the points to a particular centroid. So you can see, after this, I am assigning this. And like this, I have to do. And finally, I have these two clusters. So one is the red cluster, another one is the green clusters. So like this, you can see with each and every iteration, you can see the centroid is moving, and finally it is converged. So I have the three clusters. So suppose one cluster is red cluster, green cluster, and the blue clusters. So I have to do this. And based on this, we can do the clustering. So suppose in this figure, I have three types of colors. So maybe we can give the centroid, three centroids we can consider, centroid C1, C2, and C3. And we have to find the distance between the vectors. So in this case, we have to find the distance between the pixels. So pixel is a RGB pixel. So we have to find the distance between the pixels. Is it okay? Have you understood this one?
Yes, sir. Yes, sir. Got it, sir.
So now the main concept is randomly you have to select. The one point is important, randomly. Randomly, you have to select the centroids. And one important point is you have to give that information that I need 3 clusters for a particular application. I need 4 clusters. So for 4 clusters, I have to define the centroids.
Sir, region splitting and merging are the same thing. This is also comes under Clemens clustering.
No. Region split is different. It is different.
Okay.
It is different. So that's for segmentation. You can see this, my video, and concept is that is the main concept. That based on the segmentation application, you have to define the number of centroids. And that is the disadvantage of the K-means clustering, because that information you have to give. So how many clusters will be there? And after this, randomly you have to initialize the centroid. And after this, you have to update the centroids. So you have to do the updating of this.
Okay. Thank you, sir. Thank you.
Hello.
Hello. Yes.
Yes, sir. My name is Vedant, and sir, while registering this course, I thought that there will be no mathematics, but I'm finding very difficult when it comes to mathematical applications in this course. So, how can I overcome this difficulty?
So, can you tell me what is your background, engineering background?
So, I am a mechanical engineer.
Oh, then you should know, no? The basic is only the linear algebra and probability.
Yes, sir, but I have a gap of 2 years in education. Actually, I'm working in a company, so I don't have a connect to mathematics that I have learned in engineering. So, do I have to revise all the mathematical concept in order to understand it better?
No. All the mathematics concepts are not important. Only the linear algebra is important, and also a part of the probability.
Okay, and what else do I have to prepare in order to understand it?
So you basically, because you are from the mechanical engineering background, so what you can do, you minutely observe the video, you minutely see the videos.
Okay.
And after this, you just try to make the notes of this.
Okay.
And also maybe you can see the books. Books already I have mentioned in my first class. So what are the books you have to see? And after this, these assignment problems you try to solve. In the
Okay.
exam, you will get only 40% mathematical questions, so the remaining concept oriented. 60% will be the concept oriented. So if you minutely understand the video, if you minutely see the video, then you can get the concepts. And based on this, you can 60% marks you can get from the concepts. 40% mainly from the mathematics part. And that also, I think out of 40, at least you can try 15 marks or 20 marks you can get.
Okay, sir. Thank you.
So
That is not a
can you
difficult.
share the book's name? One books I have already in our library that last class I told you.
What
Any
book?
other books which the books which you are talking about, na sir, you shared in the first class that maybe I missed it, sir. Can you repeat it again? Because one book that you have written, it is with us. It is in our library, Amity University.
So what is the name of the book?
Sir, your book's name, sir. Computer Vision Technology, MK Bhuyan.
Okay. So that book also you can see the book by Gonzalez, Image Processing by Gonzalez. Image Processing by Gonzalez book that is also available online. You can download that book also.
Sir, any specialized book related to linear algebra for computer vision technology?
Linear algebra book also available in the online, and like the Gilbert Strang book is available.
Sir, but that book is only related to that not application part. It's only mathematical part. If anything, application oriented, sir, only in the computer vision area.
No books are available like this. So like the Gilbert Strang book is available, and for probability, Leon Garcia book is available. Stark and Woods book is available. So this book, if you understand this concept, then I think you can correlate with the computer vision concepts.
Yes, sir. Yes, sir.
If you have a linear algebra book, then you can see what is the affine transformation. So that book, I think you have, no, Gilbert Strang book.
Yes, sir. That book is with us.
Okay.
And another book says Stark, which you have said.
And that is the probability, Stark and Woods.
Stark and Woods. Okay.
And another one is for electrical engineers, the Leon Garcia. So these books are actually available online also. The Gonzalez book is available online. And another book also you can download, the Image Processing by A.K. Jain, Fundamentals of Image Processing by A.K. Jain. Fundamentals of Image Processing by A.K. Jain. That is also available online. That you can directly download.
Yes, sir. I have the same problem with the previous person because I am also from an engineering background, but not so much strength in mathematics. Right now, I'm doing my PhD in the computer vision area. So I'm facing a lot of difficulties.
No, mathematically, if you want to do something in computer vision in machine learning, your mathematics should be very, very strong. So without mathematics, it is very difficult to do research in machine learning, AI, or in computer vision. So
that's why exactly, sir. That's why exactly, sir, I wanted to mail you because which part of the mathematics is actually required to build up my algorithm. If you can help me, then, sir,
mainly already I told you, mainly the linear algebra is the main thing, and also the probability and the random process.
Okay, sir. Okay.
That is the fundamental, because calculus, in class 12. So calculus is not a problem. Calculus, everybody knows calculus. So only problem is the linear algebra, and another one is the probability and the random process.
So multivariate calculus may be the requirement. So multivariate calculus 12th standard mein nahi the. That's
but that is not a difficult one, because that is not so only that Monte Carlo simulation. Some applications are there in Monte Carlo.
Okay.
But otherwise, the linear algebra, if you know the matrix concept,
yes,
what is the multiplication of two matrix, eigenvector, eigenvalues, rank of a matrix. So this type of things.
Yes, sir. Thank you, sir. Sir, I will mail you, sir. Formatting my entire things, I will mail you. Please reply me, sir, if you have a time, sir. I'm actually formatting what exactly regarding my PhD area. If you guide me that how step by step how should I process further. So I'm just formatting my entire mail, and very soon I'll share the mail with you.
So you did you are doing from Anna University, no?
Yes, sir. Yeah, Anna University, sir.
Okay, then what you can do, you send a mail to me, but in the subject line you mention about this discussion, NPTEL.
Yes, sure, sir. Sure, sir. Okay, okay.
Generally, what we have so many mails from the
Yeah,
students.
I got it. Yeah, you told me in last
So
class.
very
Sure,
difficult to
sir.
see you.
Sure, sir. Sure. Thank
Oh,
you, sir. Thank you.
oh, oh. Book by A.K. Jain. Yes, A.K. Jain.
Hello, sir. I have one more doubt. Uh,
Yes,
so,
please.
I think that, as per my understanding, uh, image processing is a fundamental part of computer vision. Okay.
Hmm.
Uh,
Hmm.
so, in order to master computer vision, we need to have a very strong fundamental of image processing. And
Now,
after that,
image processing is a subset of computer vision.
okay,
So, if you see a typical computer vision system, the first one is, if you see, the first one is the image or the video acquisition. So that is why we discussed the concept of the model, the concept of the light radiometry. That is the image acquisition system. After getting the images and the video, the next step is the pre-processing. So for the pre-processing, we have to consider the image processing. That is the part of the image processing. Like if I want to improve the contrast of the image, if I want to improve the brightness of the image or any noise removal, then we have to consider the image processing. That is the pre-processing. And after this, the next step is the feature extraction. So currently we are discussing the feature extractions, all the features. And after this, finally, the classification and the recognition. So that means computer vision has all the things. First one is the image processing. Second one is the computer vision has two parts actually, feature extraction and the classification. So that is why the machine learning or any AI or deep learning is a subset of computer vision. So under computer vision, you have the image processing, machine learning, deep learning, or maybe the AI. So that is the case.
got it.
So for image processing, it is not a difficult one because you have to do the pre-processing. So how to remove the noise, how to improve the contrast. So these type of things, how to do the segmentation. These are image processing. That is the pre-processing. After doing the pre-processing, next one is the feature extraction. So that is actually the part of the computer vision. And after this, after getting the features, you have to do the classification. And based on the features, you have to do the recognition. So that is why the machine learning or the deep learning is important. So that means you can see that image processing or the machine learning is a subset of computer vision.
Okay, sir, got it.
So one question is how to create an algorithm similar to CNN and its library. So this programming assignment will be discussed in application number in the week number 12. So you can see some programming assignments in week number 12. And also you can see the programming assignments in my YouTube video. In the YouTube video in machine learning and deep learning, I have 42 lectures on machine learning and deep learning. So in that videos in the YouTube, you can see the programming assignments like CNN, the concept of the CNN library. So that you can see in the videos. So in the week number 12, we are going to discuss the programming assignments. And also in the machine learning and the deep learning, my NPTEL course, you can see some programming assignments that was discussed by the TAs of the course. So CNN, anyhow, we are discussing in this course. So Subrata Sarkar, sir, will it be any computing part in the course? No, there will be some the programming assignments in week number 12. And mainly we are considering the Python programming. So that OpenCV Python is there. So you can see the programming assignments there. So one question is, sir, running TensorFlow in Linux. I don't know about the Linux. And so maybe you can discuss with the TA. TensorFlow I am working, but I don't know what is the problem in the Linux operating systems. So maybe you can discuss with the TA, but I think they are also working in Windows platform. So Linux, I think 1 or 2 students they are doing. So maybe you can discuss with the TAs of the course. So Sudhakar, how much depth we are going in this course, sir? No, it is actually we are discussing all the fundamental concepts of the computer vision. So for advanced concept like now people are using the deep learning techniques. So we have introduced that deep learning techniques can be used for computer vision. So in week number 12, week number 11, we have discussed about the deep learning techniques. But these fundamental things, all the fundamental things we have discussed, and you can see the books on computer vision. So mainly these are the concepts, important concepts. So if you understand this concept, I think to understand the advanced research papers on computer vision machine learning, that may not be difficult. So this is for the fundamental concept. This is for the background in computer vision. So without understanding this concept, it is not possible to understand the advanced research papers in computer vision machine learning. So that is why I suggest you see all the videos, read the books, what I mentioned in the lecture. Then you can easily understand the research papers. There are many things are going in computer vision. So it is a very dynamic field, computer vision, machine learning, artificial intelligence. So daily it is changing, but for understanding this concept, you have to understand the fundamental concepts. So that is why these concepts are quite important. And daily you can see there are many changes in the concepts like in deep architectures, in CNN, all these things. Now the AI, the LLM is coming, the large language model. So everything is coming, but for understanding this concept and to develop a new algorithm, your understanding the fundamental concept is quite important. Then only you can develop some new thing. So if you want to write a paper, research paper, so directly you cannot do just copying and pasting it is not possible. So if you want to publish a good paper that your understanding will come, then you can develop something totally new. So new, the novelty will come, then the publication is possible. Otherwise, just writing the program and just seeing the existing papers, that will not help you in writing a paper or publishing a good paper in the journal. So for this, your own contribution, the novelty is important. So that is the novelty in the contribution. That is quite important. And unless you do not understand this concept, your idea will not come. So how to develop the algorithm, how to propose a new thing. So that is why the understanding of these fundamental concepts are important. Otherwise, you cannot understand all the papers, research papers, and you cannot develop your own algorithm. That is the proposed algorithm, and that novelty should come in the proposed algorithm. So without novelty, it is not possible to publish papers, research papers. So directly writing the codes and copying from some papers, it is not possible. So if you want to publish good papers in the journal, novelty is the one important aspect. And for this, the fundamental understanding of these concepts are quite important. So that is the importance of this course. You have to read the books, you have to see the videos, your fundamental will be strong, then you can develop something new. That is the and one thing you should every day it is going on. So that is why I suggest you see all the videos, read the fundamental books, all the books. And after this, you have to go to the next stage to see the research papers. You have to download the research papers. You have to see what they are doing. And based on this, your thinking will be better because you have to go for the advanced thinking in terms of mathematics. And after this, you can propose something new. That is the objective of this course. Okay, so you asked the Sudhakar, you asked me about the next our meeting. Next our meeting is another live session will be there in the month of March again. So I think another live session will be in the month of March in. So that day also we can interact. So that is possible.
Hello.
Hello.
Yes, sir. I
Yes,
need
yes.
to advice from you that I am planning to do my master's from Germany in the field of mechatronics, and there is one elective called computer vision. So, how should I approach that elective and make career out of it?
So mechatronics is actually, if you see the robotic vision. So in mechatronics, one part is the robotic vision. So robotic vision is nothing but the computer vision. So robot can see objects, robot can catch the particular object. So that is actually the robotic vision. So robotic vision is a subset of computer vision. So in mechatronics, that field also you can explore. That is the robotic vision. One application is the robotic vision. So your understanding in computer vision, machine learning, AI, that will help you in robotic vision. That is actually under mechatronics.
Okay.
So you can take some projects on robotic vision. Because robot has eyes also, no? Robot has cameras, two cameras or maybe one camera or multiple cameras. And suppose the robot is moving, the path planning of the robot, or maybe the robot is catching some objects, taking some objects. So like this, robotic vision is quite important. So in the mechatronics course, so that you can take as a project, or maybe that application you can consider the robotic vision. The robotic vision is a subset of computer vision.
So, sir, that course is more inclined towards vehicle, so commercial vehicle technology.
That like autonomous vehicle driving, no? Autonomous vehicle. So autonomous vehicle driving is also the part of computer vision. That autonomous navigation. This driverless car, no? You mentioned about this.
Yeah.
So I can show some of videos. I can show like this. My students are doing. I will show some videos. Is my screen is visible?
Yes, sir.
Let me see. Let me check. It may not be available. I have to see my pen drive. So you can see currently I don't have, actually it is not in my pen right now.
No problem, sir.
This is actually for autonomous driving, no?
Yeah.
That we have this type of image processing techniques. So like this, the segmentation, semantic segmentation. So if you see in my web page also, you can see some research papers on semantic segmentation. So just you see in my website, you can see some journal papers on semantic image segmentation. And that is mainly for the autonomous driving. So that is actually the driverless car. We are doing that one. So
okay.
This video, actually, I have some videos. So that was very interesting actually. It will be available. No, currently I cannot show this video. It is not available in this laptop.
Okay, sir. So, sir, how should I approach that autonomous vehicle part?
One problem is the segmentation is a problem. No, this you have the camera in the vehicle, and the one problem is the depth estimation, because one car is moving, one object is there, the tree is there, building is there. So like the depth estimation is one important problem in image segmentation. So that I discuss in the stereo image. If you see that we can determine the disparity, and from the disparity we can determine the depth information. So your vehicle is moving and the depth information is quite important. So one car is very close to you, another car is far away from you. That is actually the depth information. So with the help of this one or two cameras, nowadays one camera is also sufficient. That is the monocular imaging, or maybe you can consider multiple cameras. And with the help of this, you can determine the depth information, and also you can do the segmentation, the image segmentation. And that image segmentation is called the semantic segmentation. Semantic means one person is there, that has a meaning. One building is there, that has a meaning. One tree is there, that has a meaning. So based on this, actually, we can do the segmentation. And that is called the semantic segmentation. So in autonomous driving, that is also one research problem. And that is actually the computer vision problem application. And already I mentioned that in mechatronics, one important problem is the robotic vision. Robotic path planning, no, robot is moving in a particular direction, and that automatically he can go to a particular place. So that type of robotic path planning, that you can consider.
Okay. So in order to get hand on autonomous system, so I need to be good at image processing, then computer
vision, mainly computer vision, because now you understand what is segmentation, what is image processing. So you understand now after doing this course. Now after doing this course, you have to read the research papers. Then you can easily understand the research papers. There are so many papers, thousands of papers, research papers. And after this, you have to read the recent papers, what they are doing. And based on this, you have to develop something new. So if you want to go for research publication, the new publications, then you have to develop some new algorithms. And that is based on your understanding of the concept. So one application in the mechatronics already I mentioned, no, the semantic segmentation is a problem. One.
And one is robotic vision. Yeah.
Robotic vision, that is better to do some projects on robotic vision, because that is more related to your mechatronics course. Mechatronics is the combination of these two. One is the mechanical aspect, another one is the electronics.
Sir, for that I need to understand concept of robotics as well.
No, robotic only, no, not required. Only the camera is important, no? Other things, the mechanical things are not important. Only the cameras are important.
Okay. Got it, sir.
You need not consider all the mechanical things. You need not consider.
Yeah, I got it. I got your point, sir.
Because your research robot has the many things. Eye is there, the other things are there, the mechanical parts. But only you are doing the research on eye and the brain.
Yeah.
So your brain is the processing and eye is the camera.
Yes. Thank you, sir, for your kind advice.
So Germany, which institute, which university? University of Munich?
RPTU Kaiserslautern, in which there is a course called Commercial Vehicle Technology.
Okay.
So in that there is a module, autonomous vehicle is there. So many students are doing research in that module. So I think that I can explore that module very well. So I am thinking to go this winter semester.
That is not bad actually. That is good.
Yeah.
So I generally go to University of Munich most frequently. So maybe next semester I'll be going for 2 months to University of Munich.
Okay. So I was also planning to go in that university, but recently they have introduced tuition fees that is roughly around 5,500 per semester. So it would
Oh,
be very to study there right now for non-EU students.
so you are BTech from where?
So I have done BTech from COEP, College of Engineering, Pune. It is a government college.
Yes, I know that one. I know. Yes, College of Engineering Pune. I know that one. So now you are planning for the masters.
Yeah.
Are you getting the fellowship?
No, actually, there is no tuition fees in a German public university.
But the living expenditure, no, whether they are providing or not.
No, that we have to manage.
Oh,
Hello,
So
sir.
your
Good evening.
course
good
was
evening. Good
very.
evening.
Thank you.
Okay.
Hello,
Okay.
sir.
Tell me. Yes. Yes. Anand.
Sir, good evening, sir. Yes, sir. Yes, sir. Sir, I have a small doubt. Sir, in our course pipeline, do we touch GAN or GAN cycle?
I think GAN is also there. I think otherwise GAN you can see from my video.
Okay,
The
sir.
video is in the YouTube.
Okay, sir.
So that course is the machine learning and the deep learning fundamentals and applications.
Awesome, sir. Okay, sir.
So that you can search in the YouTube and then you will get the concept of the GAN.
Got it, sir. Got it, sir. Thanks a lot, sir.
Oh, okay. So if you have any questions, then you can discuss with me. So
Sir, I have another question.
yes, yes.
Yes, sir. Sir, while auto retraining the model, so like there are two graph generates. One is like accuracy graph. Yes, sir. So one is accuracy graph, and another is
That
like
is what is the problem actually? The problem? Can you tell me the problem?
sir, actually like it is like phase prediction, sir, which is oriented to GAN and GAN cycle. Hello, sir.
Yes.
Yes,
You're
sir.
audible.
So,
Yes.
yes, sir. So it is like we are using some GAN cycle, CNN, and by using this, we are generated some auto prediction segments, sir. In that,
Okay.
yes, sir. In that, result will be I will be uploading a small image, so it will be giving us output maybe the image may be uploaded or it will be automatically captured. So after capturing, it will do some pre-processing, augmentation, and everything, and at last it will give an output. So in that output, it will show that this will be the this is the predicted accuracy in confidence level, maybe 1 or maybe 1.00 so and so. And this will be
What is the
validation
prediction? What is the prediction?
1.0 confidence, sir. Image prediction. Comparison of image prediction.
Your input is the image.
Yes, sir.
And you have to show that this is the name of the image.
Right, sir. Right, sir.
Okay.
So in that,
So this is actually this is called the content-based image retrieval.
got it, sir.
So if you this concept is called the content-based.
Okay, sir.
Content-based image retrieval.
Okay, sir. Okay, sir.
So that means you are giving the image and suppose name of the image and it can be retrieved from the memory.
True, sir. True, sir. True, sir.
So this is something like the Google search is there, not text search.
Yes, sir.
This is the image search.
Got it, sir. Okay, sir.
So image also you can search. You just give you give the image, and
Okay.
from the database, that particular image can be retrieved.
Got it, sir. Got it, sir.
So that is actually called content-based image retrieval.
Okay, sir. Got
So
it,
you
sir.
can see some research papers on content-based image retrieval.
Okay, sir.
So your input will be image,
Okay, sir.
and that particular image can be searched from a big database, very
Okay,
big
sir.
database.
Okay,
And
sir.
within a second, within a microsecond.
Okay, sir.
So that is possible nowadays. So like the text searching, now image searching is possible. The video searching is also possible.
Awesome, sir. Okay, sir.
So
Thanks a
this
lot,
one
sir.
student, he asked me about this content based, no? Who asked me that? So he asked me about the autonomous driving, no? Sudhakar, or I forget.
Yeah, sir. Yeah. In there you were explaining about this semantic segmentation, so and so.
So I can show the video now. Video is now available.
Awesome,
I'm
sir.
sharing the screen.
Yes, sir.
The screen is visible, no?
Yeah, it's fully visible, sir.
You can see this is. You can see that we are determining the depth and the disparity. The car is moving.
Yes, sir.
This is the disparity information, the depth information we are getting.
Okay, sir.
And accordingly, we are moving the vehicle. We are moving our vehicle moving, and we are determining the depth information and also the disparity.
Got it, sir.
So this is actually I discussed in the stereo vision. If you see the fundamental concept of the stereo vision,
Yes,
with the
sir.
help of two images, the left image and the right image, we can determine the disparity and also we can determine the depth information.
Got it, sir.
And this is actually the one example of the semantic segmentation.
Okay, sir.
So this is actually available in my research paper.
Awesome, sir. I'll go cross study.
So one
Sir.
student, he asked me about this robotics. No, I forget his name actually. So that is the video.
Okay, sir. Thank you, sir.
So one question is, Sudhakar, auto vehicle not approved. I don't understand what is the meaning. Auto vehicle not approved means what is the meaning of this? What your question I am not getting. Can you explain me what is the meaning of this? The autonomous vehicle. Autonomous vehicle. Yes. That European Union did not give the approval of the autonomous, but now research is going in this direction, and many things are now going on. So that is another important thing, like legal bindings. So we are not discussing about this. We are not concerned about the legal bindings. But as a researcher of computer vision, AI, machine learning, we have to see how perfectly we can consider this case, autonomous vehicle. Because now research is going on, and maybe within 10, 15 years, or maybe within 5 years, we can get this perfect system so that it is possible. In USA, it is now going on, autonomous vehicle. But in Indian scenario, it is difficult because the image processing things like so many people in the street, illumination is a problem. illumination is not uniform illumination, lighting is not good, and also the shadow and other problems. Shadow is also a problem. So that is why it is not possible in India nowadays. So, but if you go to New Zealand, Australia, or maybe some places of the USA, this also autonomous driving is possible, and the research is going on so that we can make the system more perfect. So it should be 100% perfect. Then only it can be deployed in the practical case, like in the street of the Indian street, or maybe the crowded street. It is possible, but nowadays, as of now, it is not possible because of the problems in the illumination, shadow problem, and also the complex background. The background is very complex. So for this, the image processing is quite difficult. And also the real-time implementation, because everything we have to do in the real time. So that is also one problem in the autonomous driving. So any questions? Or because we have to conclude this session. Okay, then thank you for attending this live session. So this is the second live session of the course on computer vision and image processing, fundamentals and applications. So maybe in the next live session, we can discuss more technical things. So thank you. Thank you. Thank you. So I'm logging out from this live session. Thank you. So I'll be meeting you again in the month of March for the third live session.
Thank you, sir.
Thank you. Thank you.